Welcome to Radical Academy. In today's video, we're going to look at logarithms. And for us to understand what logarithms are, we have to first of all to remind ourselves that logarithms are simply the inverse of exponentiation. So exponentiation. Okay. So they are basically just sort of like the inverse of each other. Now we understand that exponentiation, this actually goes back to the indices, okay, or exponents, okay. Now we are going to sort of like dive into the laws that governs logarithms, just like there are some laws that governs exponentiation or the laws of indices. Now, to begin with, we're going to start with this idea that if you have this kind of an expression, 2 to the power 2, obviously you can guess this is going to give you 4. But again, if that is the case, then we can actually map this exponential sort of like expression onto logarithmic expression. So what you're going to do is you write the weight log, okay, the log of this base, and so the log of this base, obviously to what number? To this number equals to 2. And then we can get back to this same thing, saying that this base is maintained by saying 2. What number can we actually raise to so that the answer is 4? So we know that there is only one number to which we can actually raise 2, or to what power is 2 raised, which is just 2, so that the answer is 4. So when you look at this basic fundamental deep principle, is that logarithms and exponentiation are just the inverse of each other. So it means there is a relationship when you talk about that. So when you have something like the log of 10 to this 100, okay, what do you expect the answer is going to be? So the answer is going to be just 2, meaning that we are saying that this 10 is raised to a certain power so that the answer is 100. So 2 to the power 10 to the power 2, this is going to give us 100. So we can sort of interchange from exponentiation to logarithms so that we can be able to solve some of the problems that we can meet. Okay. Now, you have, for instance, this one, like the log of 2, 8, okay? So log of 8 in base 2, you're going to have 3. So now converting this to exponential expression is going to be to, we have this, what number is 2 raised so that the answer is 8. So we're going to have 2 is raised to the power of 3 and the answer should be 8. So now you can, I'm sure, I guess, I bet that this time around you can now begin to see the relationship. Now, this log, the common log, okay, the common log or logarithms, logarithm, so this log usually means everything that you are considering is actually means base 10. Okay. Then you also have what is called the natural log or logarithm. So this means symbolically this is n, and means the base means base of what? E. So on your calculator there is a number, there is a button with a symbol E. Now this is equivalent to 2.718. Normally this is called, so there's should be a Scottish mathematician, or should be Euler's number. Okay, so Euler's number, Leonard Euler's number. Okay, so this is E. So there's a button on a calculator, ln or n. Okay. Now, what are some of the properties of logarithms? Okay. So the properties of the laws. So the laws of logs. Now the first one is the product law. So what does this law state? So the product law is that they are going to have a log of this a and then x, y, these two numbers, is the same as saying when you're multiplying two logs, simply means that you are adding them. Okay, so you just have to say log ax plus log ay. Okay, and basically you can have an example to say log 2, and then let's say you have numbers like 3 multiplied by 4. So this is going to be log 2 3 plus, and then log 2 4. Okay, so this is basically what that means. And then you also have what is called the quotient. Okay, quotient law. Now this implies that you are dividing the numbers of the logs. So let's say x by y. So what's going to happen now is this law is like log, let's say you have this log a, and then in bracket x by y, this is going to be log a of x minus, so when you're dividing, okay, you can see there, then in simplifying this, returns or actually gives us a minus, so log a of y. Okay, so what is the best example of this is that you can have now when you're dividing, I'm going to actually give you an example of that. Okay, so number 3 is going to be, so what does the power law state? So the power law is a theory, or rather this concept of you have log a, okay, and then in bracket x raised to the power something. So this is equivalent to saying this power comes this side, so n of log, so you are sort of like standardizing. Okay, so this is how you can simplify that. And then we also have what is called the change of base formula. So the change. So we also have the change of base. Now the change of base could be log a and then b. So now this means that maybe you're changing from this base to another base. So this is going to be log of whatever you're changing to, okay, of that b, divided by log of that base you are trying to change to, and of a. Okay, so this sort of like goes to division, so this and this can go out. And then the last two laws. So the last two laws is number 5, okay. So now the identity law is where you have log a, so you have the same thing. If this was 2, this would be 2, and this just gives you 1. And then now exponentially, you can say that to what number can I raise this a so that the answer is 1. So you can actually literally see that anything raised to, so you can literally see that to what number can I raise this number so that the answer is actually this. So if I'm going to actually get the same in the exponential form, the same, if the bases are the same, then the powers are also equal. Okay. And then the last one is log of 1. So the log of 1 is simply log A of 1 equals 0. What is the implication of this? The implication of this is that you convert this one to exponential form by saying, what number can I raise this base A so that the answer is 1? So this we know that anything raised to the power 0 gives us 1. Okay, so that's the most important thing to understand. Now, basically, what we're going to do is we're going to have now a bit of examples. Okay, so sort of like examples. So under the identity, don't worry about that, but I can start. Maybe let me follow the order. Okay. So on the product law, so we can say that if you have log, okay, so if you have log 2, okay, so I gave this example, just trying to go through. So you're going to have, so in product you have the plus sign in between the logs, so this is going to be that plus log 2 and then 4. Okay, now we know that if we're going to say to what number can I raise this so that the answer is 3. Now this is a bit difficult, so you have to punch on your calculator. Okay, but this one, so log of 2 3 plus, so to what number can I raise these 2 so that the answer is 4? So this is just sort of like 2, because this is easily transferable, or rather interchange to exponential form. So to what number can you raise 2? Okay, so we don't know the power, and the answer should be 4. So we know that the only power which we can raise to give us 4 is just 2. So this evaluates to 2. But for this one, it's actually very difficult. So to what number can you raise 2? To what power can you actually raise 2 so that the answer is 3? So this you can just punch on the calculator. Okay. And then number 2 is about the quotient. Now we know that the quotient is what you divide, is what you get when you divide, let's say 4 divided by 2, the answer is 2. So this number is called the quotient. Okay. Now to give an example of on that quotient, so what you're simply doing is you can actually get the same thing. So the log of 2, and then 3 multiplied by 4, so divide by 3, 3 divided by 4, this is going to be log of 2, okay, log of 2. So when you are doing the quotient, okay, dividing, then you separate the two logs by using a minus as a main operator, mathematical operator, and this is going to be this minus log of 2 4, okay. And then number 3, it was actually the power. So the power law. So the power law is that you have let's say log of 2, and then let's say 2 to the power, excuse me, to the power 4. Okay, so inside this, the power should come before the log. So 4, and then log of 2, 2. Now we know that for this, then log 2, 2. So this becomes, we know something like this is an identity. Okay, so an identity gives us 1. So this will actually simplify to 1, and you know that this will just remain 4. Okay, and then number 4, which is a change of base formula. So I'm just gonna actually do this. So change of base. So the change of base is that you have, let's say 2 log 2, and then let's say you have log 2 8. Okay, so this is going to be that you change to base 10. So we're going to have that divide by log base 10 of this, now this 2. Okay, and this will give you 0.903 over 0.301, which is just equal to 3. Now again, you have to understand that by definition log 10 can be just written as log. Okay, so again this okay, which is the same as this. Now remember that when you don't have to explicitly put 10 there, then just the same as this without 10. And the last 2 is about identity and the log of 1. Okay, so this is example 5. So when you're talking about identity, so identity, which also came out on this part, okay, this is going to be, for example, log of 5 equals just 1, because we also showed that this exponentiation, the equivalence is that the equivalence is to what number? Okay, so to what number can I actually raise 5, so that the answer is 5. So anything less to the power 1 is that number. So we get that, okay? And then the last one is now the log of 1. So the thing to understand about log of 1 is, for instance, when you have log of 7(1) is equal to 0, because the only thing that we can do that will result into 1 is anything less to the power 0 gives us 1, and this is the equivalence of this log of 1. So thank you so much. Remember to subscribe, like my video, and share. So you can find me on Facebook, TikTok, as well as YouTube. Yeah, so see you in the next video.